All right, picking up right where we left off. Cameron is 5 feet tall and casts a 12-foot shadow. So here's Cameron. He's got a cowboy hat on. And some sunglasses. Cameron's got some good drip. Cameron's also not that tall. He's only 5 feet tall. But he's got a 12-foot shadow, I guess. That's pretty cool. The shadow's 12 feet. At the same time of day, a nearby building. So not only will this be a building, we'll make it a tower. Kind of castle-like. Cast a 78-foot shadow. How tall is the building? We'll call the building B. So again, repetition, we've seen this stuff. You know, sometimes there comes a point in time where maybe you don't even have to watch the videos. You can just do it on your own. But just be very careful. We got 5 over 12 equals B over 78. Cross multiply. We're going to have 12B equals 78 times 5 is 390. Divide both sides by 12. And we're going to get the building, our tower, is 32.5. That'd be a pretty cool house if your house was just a tower. And you can go up here and just chill on the top of your tower. But nonetheless. Alright, the Empire State Building. Fun fact, I've never been to New York. I'm not even sure what the Empire State Building looks like, but we'll make it look like this. And we'll put a thing up top. Is 1,250 feet tall. At 3 p.m. Pablo. This isn't to scale. We'll make Pablo wearing some Yeezys. Pablo stands next to the building and has an 8-foot shadow. So the shadow's 8 foot. Pablo's 6 feet tall in his Yeezys. How long would the Empire State Building shadow be? So like, how long would this shadow extend? And I don't like to use S because it looks like a 5, so I'll use H because that's the next letter in shadow. But anyways, we're just going to compare 250 and the shadow length H. So the height of the Empire State Building to its shadow to the height of Pablo to its shadow. So I'm going to get 1,250 over the shadow length equals the height of Pablo over his shadow length. Nonetheless, just cross multiply. We're going to get 6H. 1,250 times 8 equals 10,000. Divide both sides by 6. And the shadow of the Empire State Building will be 1,666 feet, 0.7 feet tall. Cool. Ray is outside playing basketball. He is 5 feet tall, and at the time of the day, he's creating a 12-foot shadow. The basketball hoop is 10 feet tall. How long is the basketball hoop shadow? So, Ray, since he's playing basketball, we'll give him a headband, and we'll be making him hold the basketball. And then we got the basketball hoop. Very detailed. Alright. So Ray, again, a bunch of little people, only 5 foot tall. But maybe he's like only like 4 years old, and maybe he's a giant 4-year-old. Who knows? 12-foot shadow. Basketball hoop, actually its height to the rim is 10 feet. What's the shadow length? All right, you might be able to use common sense. Well, if this is 5, 10, 12, 24. If the height is double, the shadow length will be double. But nonetheless, let's just write this out so we can practice. And 120 divided by 5, I believe, is 24. And I don't know why I used a calculator. I already said I knew the answer. And then one more problem, and then we'll talk about more things. So to find the length of the pond, a survey took some measurements. You recorded them on this diagram. What is the length of the pond? All right. So just to emphasize some stuff, notice how this is a right angle, 76 degrees. All right. So these triangles are similar. I'm just going to make a side note, similar by angle. So this is how this works. All right. Now next, there's a couple ways to do this. What is the length of the pond? We'll call this length P for pond. I'm going to say, well, 3 to 12 and 5 to P. Those are the corresponding sides. So 3 to 12 is equal to 5 to P. And then, again, you might be able to tell like 3 to 12 is just times 4, so 5 to P times 4 you get 20. Or we can actually just work it out. 3P equals 60, divide both sides by 3, and P equals 20. All right, so just some word problems, applying theorems. This is how it works in the real life. Kind of a good review of the theorems we learned yesterday, just typical setting up proportions and solving for unknown lengths and direct measurements, really cool. All right, and then in this next videos, we're actually gonna start preparing for the test, so kind of like a little review.